I want to take a look now at the end behavior of a polynomial function. And essentially what I'm asking for here is as we go to the left, is the graph going up or down? As we go to the right, is the graph going up or down? So here, what we're looking at is, first I'm just going to direct your attention to the table at the bottom. That table at the bottom gives us an idea of what a basic polynomial function looks like. So we should be super familiar with the degree of 1, y equals x, linear function, and we've become more and more familiar with y equals x squared, a quadratic function. We haven't really talked about a cubic function, or a quartic function, or a quintic function, and it doesn't stop there, it keeps going. But what I want to point out to you are some patterns that we can see, and then I'm going to talk to you about what all of this means. So when you have a normal function of odd degree, so I'm speaking specifically about these two, odd degree like 1, 3, 5, I want you to notice that this is all positive a of x, and this starts from the left and goes up to the right. And this starts from the left and goes up to the right. And it starts down to the left and goes up to the right. So all of these are negative infinity as we go to the left, or positive infinity as we go to the right. If I had a negative in front, well then basically what would happen is my graph would just flip over and look like this. So this would be positive infinity to the left and negative infinity as we go to the right. And the same would happen here. Instead of this, I might have something that looks like this. Up to the left, down to the right. You get the idea. So now let's look at my even functions. 2, 4, it would be the same for 6, etc. What I know here is it starts up, and it ends up. And it starts up, and it ends up. So my normal function will go to infinity as I go to the left and to the right. And again, if I had a negative value in front, it would look like this, down and down. So we get the idea of the end behavior. This video isn't really about anything besides end behavior, but I do want to talk to you real quickly about something else that you might notice. If I have a degree of 2, notice I just have one hump. But if I have a degree of 3, I have 1, 2 humps at most. If I have a degree of 4, I have 1, 2, 3 humps at most. If I have a degree of 5, I have 1, 2, 3, 4 humps at most. So you can have as most as the degree minus 1 number of humps. Sometimes you won't have that many, but that's the highest that you can have. So what we want to do here is determine the end behavior of a polynomial function. And I'm just going to talk you through it, and then I want to show you some notation that you may or may not see, just so you don't get confused if you do see it. The end behavior means as I'm going to the left, what's happening? And as I'm going to the right, what's happening? So if I look at this, this is a degree of 5. And we know a degree of 5 with a positive a value is going to start down, have as many as 4 humps, and go up. So this is probably not what this function looks like, but it's the basic idea. So as I go to the left, where's my function going? It's going down forever. As I go to the right, what's happening to my function? It's going up forever. So that's the end behavior. So they might just ask you to match it with a graph that looks like this, or they might give you something that says, as x approaches negative infinity, f of x approaches what? And as x approaches positive infinity, f of x approaches what? And again, that's exactly what we've done here. It's just throwing in some notation, mathematical notation. As we go to the left, that's where x is approaching negative infinity. X is getting smaller. What's happening to y? Y is approaching negative infinity. As we go to the right, that means x is getting bigger and bigger and bigger. That's what this means. X is getting bigger. As x gets bigger, what happens to y? Y goes off to infinity. So same thing here, but be very careful because this one, notice we've got some factoring going on. This is a degree of 1 plus 3. So this is a degree of 4. The value in front is negative. So if it was a degree of 4 and positive, remember it kind of looked like this, where I had 3 humps and it was up and up. But because I've got the negative, it's going to look like this, down and down. So if they said as x approaches negative infinity, what does y do? What does f of x do? Well, it goes down. Same thing as x approaches positive infinity, f of x goes down. So that's how I would write that, or I might just be matching it with a graph that looks kind of like that. Probably a little nicer than mine. Here's one for you to try. So go ahead and try this question. Feel free to use this to write your end behavior, or just sketch a graph that shows me what it is that you that your graph is going to look like, so you know, because that's really what we're trying to do, is get a sense of what our graph will look like. So press pause, try this question, then press play to see how you did. So again, my degree here is 4, which means I'm either dealing with what looks like sort of a W or sort of an M. Because of the negative in front of the 4, I'm looking at the opposite of what I would normally expect. So I'm looking at the M. As I move to the left of my M, this is going down forever. As I move to the right of my M, this is going down forever. So both of these would be negative infinity, or just know that this is what my graph would look like.